Okay, so now we're going to prove ASA theorem. Okay, so in the last proof, we did a proof by contradiction, and in this one, we do a similar thing. So we want to assume the opposite of the conclusion. So we want to start off with assuming that the two triangles are not congruent. Is not congruent to triangle D. Wait, is this the right way? ABC, DEF, yeah. Okay. Now, if these two triangles are indeed not congruent, what that must mean is that AC is not the same as DF, because if they were congruent, then these two triangles would be congruent. So if AC were the same thing as DF, then the two triangles would be congruent. Now, it doesn't matter if they're not the same, one is smaller than the other. Okay, and what this is called without loss of generality, we can just say let AC be the smaller of the two sides. So this means AC is not congruent to DF. Okay? And you can say, okay, that then AC, or AC is greater than DF. It doesn't matter. AC is greater than DF, okay? Or DF is less than AC, same thing, okay? You should say let, because it could go the other way, and then we run the argument the same way, but on the other side, okay? So this means AC is not the same as DF. So let AC be greater than DF. Since AC is greater than DF, the distance between A and C, or the length of this line, is greater than the length of this line, there must exist some point on AC, right, G, with BG the same thing as DF. Okay, so since AC is greater than DF, right, we must have some point G on AC, on segment AC, with segment AG congruent to segment DF. Okay? Now what you want to do is you want to label these angles in order to get the contradiction that you need. Okay, so I'm going to call this angle over here 1, and then this angle up here 2. Now, 2 is not 0. That means, okay, that since 2 is not 0, right, we should see right away that then angle 1 is not congruent to angle B. Okay, look at the picture. Zoom in on this idea here, right? So what's happening in this, right? It looks something like this if we zoom in, right? 1, 2, and then let's call the whole angle B, right? So this is the angle B. 1 plus 2 is B, and 2 is non-zero. So we're going to say right away that 1, this angle here, is clearly not the same as this whole angle here. And that's just evident. We're going to say angle 1 is not congruent to angle B. And we could say since 2 is not 0, right? Since the measure of 2 is greater than 0. Okay? And we need that. We need that because this is how we're going to sort of get our contradiction. We're going to get, this is clearly true, that angle 1 is not congruent to angle B. Now, what can we say? Well, now we should see that this triangle, right? Let's look at triangle AGB and triangle DFE. Okay, what do we have in this situation? We have this, why am I losing it here? Okay, good, yeah. We have this side congruent to this side by given, right? So we have AB. So we're look at triangle AB, triangle AGB and triangle. So let's just look, okay? Let's do theory while we write it. Look at triangle AGB and triangle DFE. AB is congruent to DE. Okay, then we have angle A is congruent to angle D by given, right? This is by given. By given. Right? Both of these things are given to us. Okay, look. These two, right, are right here. This one must be true. AB is congruent. And then A is the same as D. And we concluded, we drew this up so that way AG would be the same as DF. We just said that. Okay, so we don't even need to write it again, right? So what do I have? This side, right? So let's get some contrast. Okay, this side is the same as this side. This angle is the same as this angle, and then this side is the same as this side. So by side, sorry, I drew that wrong. Why? Because not the whole thing, just AG, right? This side, AG, not AC, AG, okay, is the same as DF, based upon my assumption. This angle is the same as this angle, and then this side is the same as this side. So I have that these two triangles are congruent by side angle side. Okay, and then if we pull out these two triangles, right? So this is AGB, and then this is 1 on this side, right? This is AGB right here. I pulled it out. And then this is DFE, right? Did I write the congruence in the right order? AGB, DFE. Yes, because this is the same. What happens? Why does that happen? This is the same as this. This is the same as this. And then this angle was the same as this angle, right? So by side angle side, these two triangles are the same, which means that all the corresponding parts must be the same. This is angle 1 right here, right? Not B is just the point, right? So by side angle side, these two triangles are congruent. And then that means that 1 is the same as E because they're corresponding. So I could say angle 1 is congruent to angle E by CPCTC. CTC. And then if 1 is the same as E, what else do I have? I also have by the given that B is the same as E. B is the same as E by given. And now what's the game? 1 is the same as E. E is the same as B. Therefore, 1 is the same as B by transitivity. But why is this a problem? Clearly, we said that 1 is not the same as B. This is a contradiction. Okay. Assumption must be false. And state the falsity of the assumption. The assumption being false, this is that they're not congruent. Okay? You say the two triangles are not congruent. The falseness of that is that the triangles are congruent. Triangle ABC is congruent to triangle DEF. And now you're done.